So hi everyone, my name is Haishan Yuan. I'm a lecturer in the School of Economics. So today I'm going to talk about empirical research, empirical microeconomic, empirical methods. So before I dig into a little bit more detail on empirical research, so let's talk about, okay, what is research? So the way I see it is captured by this graph by a guy called Matt Miles. So basically, imagine this big circle, okay, this big one, as the contain the knowledge that we know, right? So initially, when we go to primary school, secondary school, we expand our knowledge a little bit, maybe bigger than that before we go to school. So this is the blue one, and then green one, we go to high school. We expand our knowledge a bit in all kind of directions: general knowledge, numerical knowledge, physics, chemistry, and so on. And as we learn more, we go to unit. The pink one indicate the knowledge and skill and things that we got. But we have specialized. So we have major, we have different degree. So maybe I imagine that you're in a master, you have this here. And as more you study PhD and so on, so you go to this dark orange one. So at some point, once you specialize, so you have to specialize to some extent because the knowledge that exists is pretty vast. And one thing that so hopefully you take away from economics is that we all have constraints. We have limited budget, we have scarce resource, and Gary Becker, Nobel Prize winner many years ago, the fundamental constraint is time. We only have 24 hours per day. And so we have to specialize at some point, so we reach the boundary of the knowledge. And there, research is about trying to expand that knowledge, right? So T.S. Eliot said, well, all our knowledge bring us near to our ignorance. So basically, the more you learn, the more you know what you don't know. And so we're getting to the boundary of the knowledge, and hopefully by doing some research, you expand the boundary, right? So that's the way I see what research is about. Okay, so how to do that? So a useful approach, which in the career of in a relatively short career that I have is so the way I see many students try to approach it is a little bit not that helpful. A more helpful way is to let's start with the questions. What do you want to know? And then you try your best to answer it. But you may not want to just reinvent the wheel. You might want to look it up and see, what others have done on that topic. So for example, we don't want to reinvent the wheel. It's a really useful one. Someone have done it. And 1,000 years ago, the ancient Greeks already figured out the Earth was round using the elementary rule, elementary 2, right? So we don't need to. Let's figure out what kind of shape the Earth is, right? So starting with the questions, and you might have some idea what the answer might be, but you want to read the literature extensively and critically. Remember all these circle that contain human knowledge. A huge chunk of it will be documented in the literature. There might be other means that the knowledge be recorded, but the most accessible and convenient way is to go to all these database, journal, Google Scholar, and so on. It's search it. So Right. So, and you might need to do this iteration a lot of time. So, for example, you might start with questions such as why some country is poor, why there's huge difference in terms of income per capita across country, right, on Earth or even within country. Okay, so chances are the first question you're going to start with either has been answered by someone, or you just can't really get that answer. Right, so a big question like generational economists have been working on why some country has been not as prosperous as other countries, right? So you are not going to spend one semester to solve all the problem and then kill the whole economic profession altogether. Right? So you might want to cover, okay, what we know, what we don't know, read the literature extensively and also critically. Right? So meaning, okay, this is convincing, this is not. And this is opinion, this is fact. Right? And then we try your best to answer it. And you might want to refine the question a little bit with appropriate methods. Right? So, for example, if you want to know why some country have been persistently low income and other countries have persistently high income, some theory will say, well, economic and political institution matter quite a lot. And then we ask, okay, what kind of institution is that? To what extent matter? Is the data supporting that? Broadly speaking, like research question, you can cover two types. One is what we call normative question, which is basically questions or statements about what should be or what ought to be. So, for example, China now they have really high unemployment rate among young people, more than 20%. If the last time the official data and recently the government figure they don't like it and just stop publishing that statistic, many people I talk to will say, okay, actually the actual number might be higher. And so what should the Chinese government do? What should the Chinese government focus on economic policy to reduce on young unemployment rates instead of picking a fight with everyone else in the world? So that's the normative questions. Positive question is questions or statements answering what is and what is not. So what is causing the high unemployment rates? Or is the tech crackdown? Is it COVID lockdown? Is it the way they implemented zero COVID and so on? So those are question and statement concerning what is and what is not. And oftentimes you might want to answer normative question, but before you be able to do that, you might need a lot of answer to positive questions. And this is where empirical method come in really handy. Okay, so other people, other guest lecturer may have or will talk about with theoretical research. That's not my expertise, so I just briefly mention my view on it. And so things like game theories. This is an analytical tool that people use to think about a lot of things: strategic interaction in business, in politics, and so on, in international relationship. This is another example of theoretical research, and a normative one, which is talk about, okay, how should we set the minimum wage? What is the optimal minimum wage policy in a competitive labor market? And so this is a theoretical paper. It uses formal theory. It's all this formal model here. It's normative. Asking, okay, what should be the optimal minimum wage policy? And then some kind of analytical or welfare criteria, which is called utilitarian. So this is formal theory. Theory doesn't have to be formal. For example, it could be a little bit more informal, verbal. So, for example, a lot of philosophers, scientists, just thinkers in general, have been asking questions for centuries. Do leaders matter for economic growth? For thinker like Leo Tolstoy or Karl Marx, they would say no. They have this idea of Okay, sorry, this I jumped up earlier than I should. But we'll get back to it. Okay, so Tostao, Karl Marx, they have this idea. I also traced that earlier as well, but let's not get into the philosophical route of thinkers. So they have this idea, historical materialism, and we're not going to go through it. If you like, you can read it, do your research, read it up afterward. But basically, their idea is that the primacy of economic and social force is what shaped the trajectory of history, the discourse of history. So there's little room for individuals and ideas. Okay, so that's the idea of historical materialism. It's really popular among economists because, well, we study economic forces. Right? And so one example of that would be kind of what Alan Greenspan, the former chair of the Federal Reserve, the central bank of the US, when he was asked, okay, what do you think in 2007? What do you think about the upcoming presidential elections? Let me just play a little bit. Okay, so that kind of short quote capture this idea that, at least in that kind of more specific issue, the idea of historical materialism. Okay, so the global market forces governing even the policy of the US and who got to be the president of US does not matter that much. So that's one kind of theory. Here we don't, it's a theory, but it's not a really formal theory. You can make it more formal, but here there's no need to for our discussion. So I'm not going to play the whole thing because we don't have time, but I'll encourage you to cover. It's coming from a book by historian Adam Tooth. What he is going to say in this clip later on is say, oh, I don't agree with that. And part of the reason is that Alan Greenspan is the one kind of shaping the globalization architect. Right? So the other view of like how, other view in terms of answering this question, do leaders matter for economic growth, is this so-called great man theory. Right? So based on that theory, the evolution of history is largely the result of idiosyncratic influence of a very small number of individuals. It doesn't have to be man, right? But the guy who coined this phrase is a man, and the society so oftentimes is dominated by the view of man. Obviously, historically, there's a lot of great movement shaping the history, or a lot of people think so. For example, if you want to learn more about how great women shape the history, there's a Harvard historian, Harvard professor Jim Lapau. He got several great books on that, including one, The History of Wonder Woman. Okay, so based on this view, another great woman captured this idea with a nice quote. So this is Margaret Mead's Anthropologies. Basically was to say, well, I never doubt that a small group of thoughtful, committed citizens can change the world. Indeed, that is the only things that ever have. So this cover Margaret Mead capture this this quote by Margaret Mead capture this idea of great man theory of history. And in this case, it's great movement because this is the Women's March after Trump's elections, right? And okay, so how should we think about the role of theories or and models, theoretical models? So the way I see it is that, well, theories are kind of like maps. Right? They are useful too. They provide conceptual framework to understand how the society works, how help us to navigate the complex relationship in the society. As a map that help us to navigate the kind of complex geography in Europe. In this case, could be in Brisbane as well. Right? So the social reality is complex and multifaceted, and to kind of help us to think about one aspect or of a problem or issue, theoretical models kind of focus on a set of crucial variables, salient features that we think are key factors, and then leaving out others. Right? So in a way, we'll kind of abstract away from a lot of factors so that we can kind of see things more clearly. It captures the most salient aspect of social interaction in a given context. Right? But the thing is, well, theory could be wrong. Okay, so I could tell you that there's a secret teapot orbiting around Saturn and secretly control the grade of all of you. Right, that's my theory. But obviously, that's ridiculous, right? In reality, theory could be less ridiculous, and it depends. Theory could be wrong. And there could be many competing theories with different policy implications. And then we want to know, okay, which theory have empirical support, right? Or what theory apply in different settings. And the data may even tell us that none of the existing theory do a good job explaining how things work. Right? So economists use statistic and econometric methods to analyze data and to evaluate empirical evidence. Okay, so that's empirical studies. Right? Broadly speaking, can cover think about empirical study into cover two types. One is qualitative one. So, for example, think about this photo. It tells a story, and that story is for this guy, which is a shepherd, in somewhere in I'm not sure where. But for the sake of this argument, let's say this is Africa about it. But anyway, so in some developing country, the guy is using a solar panel to charge his cell phone, more like a smartphone, riding on a donkey. And that's sort of interesting because, well, the story that people describe this phenomenon was, well, in many parts of the world, they have smartphones. They have even internet, but they don't have reliable electricity connected at home. So they use another more advanced, arguably more advanced technology, or at least the later technology, to charge their phone. Okay, so that's interesting, and that's a phenomenon that I, before looking at this photo, did not know. So I learned something. My knowledge got expanded as a consumer of someone else's research. So that's qualitative research. It describes something, and that's really useful. But then one might have question, okay, how common is it? Is this in one guy, 10 guys, that in a small part of area do these kind of things? It turned out that it's much more common. So The Economist, the magazine, featured an article which is built on someone else's quantitative research. And look at, okay, let's just focus on sub-Saharan Africa, right? So what is the share of population, right? They don't without access to electricity. So there's no connection to electricity to their house. And on this map, I can map that. Right? So for example, in this cover, in Niger, there's more than 75%. Right? In Sudan, it's still 50 to 75%. And then if you compare to in the same country, like what is the mobile phone penetration? Right? So here is like Nigeria is at 45%. So so in it, for a lot of people, this phenomenon where they have access to mobile phone, but not electricity to charge it, or at least not reliable electricity to charge it, connect to home, is quite common in sub-Saharan African countries. Right? So that's quantitative research that tell us how using quantities, using numbers to tell us something about economic phenomena. Okay, and here is more descriptive in the sense that it describe the data, the phenomena. Okay, so my research is primarily quantitative research, right? So and this is kind of today I'm going to talk about quantitative study using econometrics. If in particular I'm dealing more with observational data, we'll talk about what are those things. So if you think about quantitative research, would use data to try to learn about things. Okay. One kind of data is experimental data. So so here is a video that introduce you econometrics, just in case you haven't taken a course in econometrics or haven't really little idea what econometrics is. I'm sure most of you have heard about it, have some idea. Just in case not, or if you want to refresh idea, or if you want to look at it from a different perspective, this is a video, really short one. I don't think we have time to watch it during the lecture, but it's just a 3-minute, less than 3-minute video. I'll just leave it up to you after this lecture to just watch it on your own. Okay, so econometrics. So we use econometrics to deal with data, and there's many methods. One method that is really useful and common is regression, particularly linear regression. In this comic, it can describe, okay, this is linear regression. Basically, if you, for example, in this simple example, if you want to describe the relationship with of two variables, X and Y, we can discover, okay, in this case, all these are data points. And the data will tell, oh, seems to be, there's this kind of positive linear relationship between Y and X. Okay, and this comic will say, okay, nowadays there's so much alternative facts, that some people think about Trump and some authoritarian governments will say, okay, the relationship actually is like this one, which is, well, societal regressions, which is just, it's not a jargon, it's just people describing this is kind of counter to the social progress. Okay. All right. So for you, if you are really interested in doing empirical research, just be a bit careful. So even though if you want to do empirical research, empirical work should be either motivated or guided by theories. You don't. So it's a bad habit to just go out and get a bunch of data without thinking about what is the underlying research question, or just like want to go fishing and see what you what statistical relationship you find in the data. Oftentimes that's not really helpful, right? So let's go back to what I said. So starting a research project with the questions, okay? Empirical work oftentimes is, okay, for that question, this might be already several attempts to answer that with different theories. Empirical will come and say, okay, which theory have empirical support? Which theory is supported by the data, right? The data that describe our work and how things are, right? Regression, linear regression, you probably learn quite a bit in your econometric class or and spend some time to figure out how it works. But just keep in mind, regression is not, sorry, it should be neither necessary nor sufficient. Okay, sometimes you don't want to just jump in and run a regression without knowing how to interpret that regression result, right? So sometimes you don't really need to run a regression. It's much better to just describe the data well, and learn from it first before before actually running a regression, or sometimes may not be even necessary. It's much better you understand the data well, and describe your understanding than running a regression without knowing what you're doing. Okay, so and another thing is, by itself, a regression, it tells you correlation. Okay, in this cover, a cartoon illustrate that. So while it's important to remember that correlation does not imply causality. So so the first sentence is what you should remember. In this case, they have some theory, and that theory is if something goes bad, we know it's all right. Okay. In this case, the data and the theory need not sort of connect with each other. Okay. Sometimes correlation is likely, sort of underpinning a causal relationship. So this is a Google Trends in terms of like how many people are searching particular word. If you go see the graph go up, it means that the blue line is vodka. It means that, okay, a lot of people are searching the word vodka. A drink with high alcohol concentrations. And a couple of days later, the search on hangover goes up as well. Okay, so anyone would like to guess the causality, which way the causality go and why? Some hints. This is close to Christmas, New Year Eve. So in this case, it's likely that people try to get some alcoholic drink, have some fun, and they search for vodka, and they got drank a lot, too much, and the next day or they go search, okay, how to deal with the hangover. So here there's a clear correlation between the search of vodka and hangover a days later or 2 days later. And we sort of have some theory that correlation is likely causal, or at least there's a causal story, like people got search vodka, they want to look for drink with alcohol, and then later on they get hangover, they search for something related to hangover. Okay. So that's sort of New Year Eve, or the week of the New Year's, that was the peak of the search in vodka and hangover. So in that case, the correlation are likely causal, or at least there's some causal story. Here, there's another correlation. One is the house price in the US, and the other one, that's the yellow one. The other one is the popularity of babies named Ava. And we'll see there's correlation there. That correlation could be just happen by chance. Right? At least I can't think of credible theory would say the relationship is causal one way or the other. It's kind of hard for me to imagine people name their baby Ava and then house price goes up, right? Or the other way. Okay. Unless you have suddenly become a socialist country and say, okay, everyone who have a baby named Ava, the government subsidize 10% of the house price, or something like that. Okay. This is another kind of graph that we kind of see correlation. This is on the horizontal axis. This is graph from The Economist. It measured the mean score on PISA reading scale. PISA is just some kind of test of I think high school students in terms of how well they read. Okay, 600 is the best, and 1 dot is one country or economy. Who also that's the means of in that country or economy, and we see that okay, there seems to be a positive relationship. Right? They are positively correlated. Country with high income like Finland, Germany, they also tend to have high ice cream consumption per capita. Right? Here, as much as children around the world would like to think having ice cream consumption will increase their reading scale, the relationship is probably not unlikely to be causal, right? It might be that for some parents, if their children do well in reading, they reward them with ice cream, but I doubt that it's the behavior common enough that drive the relationship from the causal relationship from reading scale to ice cream consumption. Right. So in this case, there's correlation, but most likely the causal relationship is not there. Right. Or maybe there's something else driving these two. Right. Maybe the income per capita in those countries. People have more money they could afford to consume more ice cream. And the reason they have more money might be that their population better educated. Right? And there, right, so in this case, we see that correlation, but the data by itself, it doesn't tell us causal relationship, but somehow it help in terms of us stimulus to think about all kind of potential theory why we might see this relationship. Some of most of them may not be true, but at least that get us start thinking. Okay, so takeaway is captured by this comic, so the guy here said, well, I used to think correlation implied causality. And then I took a statistics class or economic class. Now I don't. So, and his lady friends will say, well, it sounds like the class helped. Right? That sounds like, right? And that statement is a causal statement. And the guy was, well, maybe. Right? So there's a correlation of taking a statistics class and not believing correlation imply causality. Right. So here again, there's a likely causal relationship. A causal taking a class caused the guy who changes belief. Right. But again, by itself, right, it does not rule out entirely all other possibilities. Right. Right. So causal relationship, cause effect is a relationship between events and things where one is the result of the others or others. Okay. I'm not sure we have time. I think we can play this. Oh, thank you.
One thing to remember is that regression analysis tells us statistical patterns in data. On its own, regression tells us correlation, not necessarily causality. Knowing correlation could be useful. For example, it could help with forecasting. Or the correlation may shed light on in what direction we should explore more in theory and data. However, to understand how society works, we need to understand cause and effect. For example, we would like to know what causes households in low-income countries to adopt technologies that improve their agricultural productivity. What causes some people to get vaccinated while others don't? Whether and by how much a policy intervention reduces poverty. The policy intervention is typically called the treatment. Those who are affected by policy intervention are treated subjects. But estimating causal effects is difficult, because by definition, causal effect compares what is and what would have been depending on whether the subject got the treatment. As Robert Frost described in his celebrated poem, The Road Not Taken, two roads diverged in yellow wood, and sorry I could not travel. Whichever road that traveler took leads to a unique path and an outcome. It is possible that choice made no difference in things we care about. But it is also possible that the choice made all the differences years later. And so, by how much? The poem highlights a fundamental challenge of causal inference, which is that the counterfactual is not observable.
Okay. So that's causal inference. Let's get out of it. Okay, so one way to tease out a causal relationship is to do experiments. And then we got experimental data. Okay. So the idea is to through experiment, and you would kind of manipulate only one thing. And so on average, the difference between two groups, right, the only difference they have is that one thing you kind of give them. So and this is like really crucial in medicines and later on to in economic. A lot of us, some people like Esther Duflo kind of pioneer this idea and then bring it into economics. Well, think about if we want to learn, okay, someone come up with a new vaccine of COVID-19 and try to figure out whether it works or not. What they do is they do a randomized control trial, RCT. So they separate a number of subject volunteers into two groups. One is given with a new vaccine. The other is given with some what we call placebo, which is something that we know is not going to help or harm them. Okay. And then later on, they come, okay, how many of them got COVID-19? And then collect the data on them. This is a kind of a graph summarizing one vaccine, the Johnson & Johnson trial. And they sort of look at, okay, in the placebo group who did not get the vaccine, 49 out of 5,000 volunteers got COVID-19. Among those got vaccine, only 17 out of 5,000 got COVID. So that would be a 66% less risk in terms of getting contracting the virus. Symptomatic, at least bad enough to have symptoms. So that's a 66% of reduction in terms of getting infected. And if they further look at, okay, how many people got serious illness? Right? In the placebo group, it will be 9 out of 5,000. And among those who got the vaccine, is 1 per 5,000. Right? That would be even a bigger reduction in the risk of serious illness. Okay. Now, like if you randomly look at two groups, okay, the difference could happen just by chance. And there where probability statistics come in. They will say, well, that kind of big reduction, the chance that the vaccine have no effects at all, but end up having this difference is extremely unlikely. Right? And I was okay, there's a statistical difference between these two in terms of the infection rate or in terms of the rate of serious illness. What's different? The vaccine, whether they got vaccine or placebo, they got randomized. So on average, these two groups should be really, really similar. And if the group number large enough, the difference between infection or having serious case, as big as this two number, would be extremely small if the sample size is large enough. Okay, so they conclude, okay, this vaccine is effective in terms of reducing infection and serious illness. Later on, a number of economists, Esther Duflo, Michael Kramer, Abhijit Banerjee, they kind of pioneer bringing this kind of technique from medical science and actual science to research on in economics, in particular on property. Okay. So they do experiment on the field, and therefore in the field, and therefore they're called field experiment. So for example, there's all kind of idea in terms of theory, in terms of okay, what can we do to reduce poverty, and particular improve people's life in particular aspect, right? Education, nutrition, and other things that people think potentially could be helpful for economic development. Agricultural productivity. Even before the COVID-19, vaccination, public health is an important topic in developing country, and people kind of struggle to get enough people to vaccinate it, not for COVID-19, but for other kind of preventable disease. So, so in one of their studies, they sort of figure, okay, how can we, what would be an effective way? And by effective, they would want to know how effective it is and how much the cost is going to be. And so it turned out that, okay, they randomize a different village into different groups, and control group, nothing happens. In this green group, the mobile clinic, they just randomize people by providing them with a mobile clinic. So in they figure theory, this is theory part, one potential barrier for parents to get vaccines for their children is difficulty and accessibility. So they might need to travel by foot for a really long time, hours, to go to a clinic to get vaccine, and that's prevent them or make it hard for them to get vaccines. And so in one of the treatment group, they sort of randomize and give some people, some villages, mobile clinic that offer opportunity to get vaccine for free. In another treatment, they will say, okay, not only you got vaccine for free, you got some food as well for staples. Okay. It turned out that mobile clinic, it boosts up the vaccination rate by from 6% in the control group to 18%, 3 times. The one with some free foods is boost the vaccination rate to 39%. Okay, more than double of this two. And then if you think about it, so in this low-income country, a small have a incentive, increase the vaccination rate by a huge margin. And if you think about it, there's a cost in terms of setting up mobile clinic. The cost of this mental health is relatively small. And if it can increase the vaccination rate a lot, on a per capita, per vaccination terms, actually this one is cheaper, even though you provide something extra. But because it's so effective in getting people vaccine, this one stand out. It only costs $28 per vaccination. And this one, it costs $56 per vaccinations. This one is still helpful, but maybe this one is even more helpful, okay? And so this is in this case, we know pretty sure that why there's a difference between this group and this group in terms of vaccination, right? And this is because this group have discount treatment, mobile clinic plus this small gift for vaccinations, right? Because whether a village fall into one of these three groups is randomized. So on average, they should be similar, okay? So that's experiment from the field. And this is one way to get a causal relationship between so two variables. In this case, the two variables is like this different kind of treatment, and the other one is vaccination rate. There's another type of experiment data. Another way to do experiment is to experiment in the lab, right? Like people sitting in front of a computer, and you give them different environments, treatment. You could have a large group of behavioral economists who do experiment and for the most part, lab experiment. So as a UQ student, if you're interested, you can always look it up and you can sit there, play some economic games, learn something and earn a small amount of money. I think it's interesting, a good learning experiment. So that's another kind of experiment data from the lab. So when I did my PhD, I went to a lab experiment once, and that's about like how people behave in auctions. So there's a bunch of auction theory in the university I did my PhD, and they try to figure out detail about these different kind of auctions. I think whether the theory work well in terms of describing, predicting how people behave in auctions, and then so that people can decide auction for different objects. Right? So for the government to auction of assets, they might want to raise the maximum amount of money and so on. And so I went to one of these. It was fun, and I have a good amount of money compared to the time I spent there, which is enjoyable. Okay, so that's experimental data. But the thing is, a lot of time, doing experiment is either not feasible or not ethical, right? So imagine that, right? For example, if you really want to know how much someone's education increase someone's earning, right? Which is a important and extensive study question in labor economics. One way to, in the data, we see with clear correlation, right? People have more education on average and more, have lower unemployment rates, live longer, all kind of positive relationship. Now, that is correlation, okay? By itself. It doesn't mean causality. In some model, like signaling model, you would say, well, even if you don't have any causal relationship, you might still see that relationship. Right? For example, the signaling model would say, well, people who work hard, who are intelligent, who are persistent, who are creative, they would have more education, even when education has no impact at all on their earning. And the reason is, well, there's information asymmetric. They want to go through getting a degree to signal to future employers that they are good, right? In an environment that employer may not know their ability, and so on, right? So how can we get, right, whether education increase someone's earning? So that's another way to put it is whether there is a causal relationship between education and earning, schooling and earning. Well, one way to kind of credibly get the answer is to experiment, right? So we have, I don't know, like 20, 30 people here. If we do an experiment randomly, half of you got kicked out of UQ and forbid to take another course forever or another degree, then would randomly change people's education level, right? But that is not feasible and not ethical, right? So because a lot of people's lives would got messed up, right? So for a lot of questions, another example being, okay, and now we have inflation, what affect inflation, what can lower inflation? Well, if we randomly just pick some country and say, okay, you have to, I don't know, destroy your, also fire half of your workers or 10% your workers and see whether inflation will go down, that would not be ethical, right? So, or feasible. And so for a lot of questions in economics, right, it's not feasible or desirable to do experiments. Then the question is, well, can we still learn about causal relationship, right, using just the data out there, which is we call observational data. A lot of questions in economics are like that. Okay, so in the next part, we're going to talk about, okay, how can we try to use observational data to try to get some of the causal relationships so that we can understand things better in terms of how the society works. Okay. Should we have a break? Is it usual practice to have a break? Okay. So how about we have a break for 10 minutes and then we'll come back 11 and we're going to talk about how econometrics could help us to deal with observational data and some kind of suggestion about research in general. So let's get back and talk about observational data or research related to using observational data. So remember what we kind of talked about before. One kind of question people have been wondering for a long time is, like, do leaders, national leaders, matter for economic growth in a country or economy? So Karl Marx, Leo Tolstoy, and people having this idea, historical materialists would say, no, individuals don't matter on average that much. Okay. People having this great man view would say, no, I mean, a small set of people matter quite big. So people have been, like philosophers, political scientists, economy have been debating about this for a long time. And people don't really get so good conclusions in terms of people have some idea that, okay, economic social force matter, but do leaders, individual leaders matter for a big picture things like economic growth or trajectory of a country? So more recently, two economists, I think Benjamin Zheng was from UC Berkeley and Ben Elkin from MIT, have this kind of really innovative idea. And this is illustrate how people use observational data and try to figure out as best as they can a causal relationship really well. The idea is using what is called natural experiment. So if you think about it, if someone tried to answer this question doing an experiment, it would be just randomly remove leaders or randomly assign different people to be national leader. And we know that that's not feasible. So in this paper, what they do is, okay, let's look at a set of leader that they just die in office, okay, for maybe heart attacks and so on. Okay. Now, a correlation between some leader have certain characteristic, like education, tenure, age, and economic growth. Those correlation does not tell us a lot in terms of causality. And maybe someone managed the country well, and so they have high economic growth, and they got to stay in it for a long time in the office. Or maybe someone who who is really bad at managing the economy, but they're so entrenched in the office, right? In particular, in authoritarian country, but it just has to be that case, where they just stay in forever, right? So correlation could go either way, and we don't, right? There are all kinds of theories that would tell us for one way or the other. And so by looking at the observational data, right, we really don't have a good sense how to answer that. And here, the idea was, okay, let's see what happens if they just happen to die in office, and then a country have to change its leader, and see what happens, okay? And here the idea is if people for kind of reason just die in office, it's kind of like the nature is doing experiments, right, in the office of national leaders. And they find like robust evidence that like leaders matter for growth. Okay, so so if they change national leader, the growth trajectory change, the growth rate change. And the results are more the strongest in autocratic country where there are few constraints on leaders' power. Right? So maybe in Australia it doesn't matter that much because, well, individual leader may not have all that power to decide all the policy. Right? So Australia have a parliamentary system, the cabinets with a lot of ministers collectively decide national policy. And then there's other states in a federal system decide state level policies such as health and a lot of local issues. But on the other hand, in autocratic country, basically one guy, and almost always is a guy, unfortunately, would say, well, like this Flatless is president of Cote d'Ivoire, would say, well, there's no number 2, 3, or 4. There's only number 1, and that's me. I do not share my decision. So this is one example where they try to attempt to piece out causal relationship by using observational data. Data to just observe like what kind of person who are national leader, and what is the growth rate in that country. Using natural experiment to someone. But you might ask, well, maybe just people die in office. Doesn't mean that their deaths is close to random, because historically we're leader with all kind of events, incident where national leaders dies not that unrelated to other things, right? there's assassination, there's coup d'etat, there's people maybe even work too hard or party too hard to deteriorate their health and so on. Right? So in a follow-up paper, the two take it a step further and say, okay, to deal with that potential issue, we push it a little further. We look at just assassination, in particular assassination attempts, where people try to assassinate the national leader. And sometimes I look at US, for example, a lot of presidents got assassinated. There are a lot of assassination attempts on the president, Reagan's, Abraham Lincoln's, and maybe many others we don't know about. So in the case of Abraham Lincoln, that was successful, but Reagan, it was not, although some other people got hurt. So what they look at it, okay, sometimes just the bullet hit the president, and other time they don't. So that's hence the title, hit or miss. In that case, arguably things are much more random. You can imagine a lot of factors that cover affecting whether the bullet just miss the targets. And so they look at that subset of events, and that arguably was closer to a random experiment that nature just run in history. So what they found out, well, on average, successful assassinations of autocrats produce sustained move toward democracy, and have some impact on small-scale conflicts. And the result cover document a contemporary source of institutional change. So apparently, this quote by Benjamin Disraeli on the death of Abraham Lincoln's assassination has never changed the history of the world was wrong. Cover observationally, we can't know. Historically argue that if Abraham Lincoln was not assassinated, his policy would be probably more lenient toward the South, more reconciliatory, and so on. But we don't know for sure. From this study, on average, we know that institution change in the country, and so leaders do matter, either directly on economic performance or indirectly through economic and political institution in the country. And this is from that graph. Obviously, so this is in a way more more event study, as illustrated this graph. China, for example, this is the death of Mao, Chairman Mao, and things changed after that. After a couple of years, Deng Xiaoping got into power, or returned to power to some extent, arguably have this reform and opening up, and then China just follow another trajectory. Here, the dip of that economic growth was a great, one of the largest or the largest famines in human history, where more than the population of Australia just died. So this is one example where empirical study use observational data and to answer the question of do national leaders matter? Those are a positive statement. Does it matter or not? This is not a normative statement or answer a normative question. Obviously, just because it matters doesn't mean that there should be assassination, right? So there are a few econometric methods that are quite useful for us to sort of take observational data, leverage up through natural experiments, and get a causal relationship. Here, it's a nice book by Joshua English, MIT economist, I think recently got the Nobel Prize in economics. So one is called regression discontinuity.
The many projects financed by the European Union, some are more effective than others. The evaluation of policies is a key factor in understanding their impact. Regression discontinuity design, or RDD, is a powerful counterfactual impact evaluation method. Consider a program to support the job search of unemployed workers who are 25 years old or younger. How effective is the program in increasing their chances of finding a job? RDB looks at individuals who are slightly above the age of 25 and at those who are slightly below it. The fact that rules can be discretionary ensures that people close to the threshold are very similar, except for the fact of participating in the program. For example, consider Group A of unemployed people aged between 24 and 25, and Group B with ages between 26 and 27. These groups should have, on average, the same income, education, motivation, etc. Only Group A can take up the training, whereas Group B is excluded. The difference in the average employment rates between the two groups, the so-called RDB estimate, can hence be associated with their participation in the given training. Regression discontinuity design takes advantage of precise knowledge of threshold rules that determine participation in a certain program. This makes the regression discontinuity design a very powerful method to evaluate the impact of policies, and therefore helps to improve the design of future policies. For more information, visit the JRC website on microeconomic evaluation.
Okay, so that I give you some idea of a really useful methods, regression discontinuity design, in terms of answer some positive research questions. And here is another example where people are trying to figure out whether minimum legal drinking age matter for public health, in particular traffic accidents. Right? So in the US, in most states, the minimum legal drinking age and the minimum age that people can purchase alcohol legally is 21. Okay, so 21. In Australia, I think it's 18. And then they try to figure out, okay, does the policy affect motor vehicle accident, right? Or affect people dying from motor vehicle accidents? Okay, there might be theory will say yes, and there might be say no. Right? The theory will say yes. Well, young people, they may not be as careful, or on average, or less experienced. And there's an environment where there's, in some places, maybe strong drinking environment, and peer pressure may induce people to do things that they otherwise should not do. So if they drink and drive, that's dangerous. They might get into an accident and they might die from it. Yeah, the other theory will say, well, maybe not. If you don't have legal minimum drinking age, people might be rational enough to say, okay, I drank, but I don't drink and drive. Or there might be theory will say, well, even though you have this minimum legal drinking age, there might be other ways to get alcohol without get around the law. Okay. So in this paper, this research, I sort of figure out, okay, let's look at people's deaths per 100,000 person per year, and look at people at different age. So each one dot, I'll say, okay, this is like people 19 years old, or actually 19 years old, and this is 19.1 years old. What is the mortality rates due to different reasons? And here is due to motor vehicle accidents. So it's 35-ish per 100,000 person per year. And as people kind of get older, actually there's a downward trend, like people may be less impulsive, more as people get older, on average, they be more careful, or maybe just more experienced in driving. But at the 21 years mark, despite this downward trend, there's a sharp increase in the number of people who die from motor vehicle accidents. Okay, and then afterward it continues this downward trend. So what happened at 21 years old? Well, in most states, that's the age at which people become people can legally purchase alcohol. I remember this is one bin is really small, it's just 0.1 year. So in a month or maybe 1 month later, right after they turn 21, there's a sharp increase in the likelihood that they are going to die from motor vehicle accident in the populations. Nothing else changed except the legal minimum drinking age. And if we look at other reasons people die, internal causes, there's a continual increase and suicides of blacks. And so these two things, there's no discontinuity, at least not statistical significant jump when people turn 21. And so here, it illustrates that there's something we call running rebel, and that's age. And then as people become, the correlation itself, it doesn't mean people just drink and drive, right? But the jump here demonstrate that the discontinuity shift in people probability. And what changed there? Well, no other thing except the minimum legal drinking age. So this paper is going to illustrate that, wow, yeah, so here a lot of, not all people, but a large enough number of people, young people, when they turn 21, they can purchase alcohol legally. And there's a higher likelihood they drive under the influence of alcohol and get into motor vehicle accident. Okay, so so here I answer the question of does minimum legal drinking age matter? Okay, in terms of is there a causal relationship between minimum legal drinking age and people dying from motor vehicle accident? Now, this may not directly tell you the answer whether you should set minimum legal drinking age or what age that should be. Right? But at least it's good to know that, well, it matters, right? So that is regression discontinuity design. Right? Just because another thing about it is that in a small neighborhood close to that cutoff, I think about 1 month before your 21 years birthday and 1 month after, or even 2 days or 1 week. Things are otherwise similar, but on the other side of that threshold, 21 years old, you could purchase alcohol legally, and 1 week before that you cannot. So it's kind of like within that small neighborhood, there's some kind of randomness there, and that randomness affects whether you can purchase alcohol legally, and that's the treatment. So it's kind of like in an RCT where you kind of randomly got vaccine, except that here there's no someone who decide experiment consciously and randomize group in the group, but rather it's kind of a nature as if you got random. So in that neighborhood, it's close to random, and that's how in this natural experiment where you sort of make use of this technique called regression discontinuity design to make experimental environment and get the causal relationship. Okay. So this is like one method that is useful to cover use natural experiment observational data to get a causal relationship. Another really useful method is called difference in differences, or we call diff in diff. And that's the idea is we look at a comparison group, the control group, that is likely to have a similar trend, or technically we call it parallel trend of outcome in the absence of intervention. Okay, so so idea is the control group and this trend provide an estimated counterfactual outcome. So this is what they would like. This is the control group would have got if they don't got the treatment, right? And so the why it's not different if the first difference is the treatment control different before the intervention. Intervention could be, I don't know, some training program, all kinds of things that you are interested in your research question. The second difference is the treatment control different after the intervention. And then we'll take the difference of these two differences. Okay. So, and the first difference is help us to get this counterfactual of the treatment if they don't have the intervention. And this is the slides, the video illustrating the idea.
Projects outside the European Union, some are more effective than others. Choosing the most effective ones is important to give good value for money for the European taxpayers. The EU also oversees regulations that aim to protect its citizens' health and safety and improve the functioning of the single market. But is regulation effective? One way to establish this is using the method of difference in differences, diff in diff, one of the counterfactual impact evaluation methods. Consider some regulation preventing too-late payments in commercial transactions. How do we know that the regulation was effective? Assume we have access to data for two groups of firms, where one of the groups, Group A, was exposed to the regulation, while the second one, Group B, was not. Assume also that both groups are observed for two time periods, 1 and 2, one before and one after the introduction of the regulation. Then consider the difference in average payment days in both groups between period 1 and 2. Other factors like growing use of electronic payments may have affected both changes. We can use Group B as counterfactual, which is what would have happened to Group A without the regulation. The difference between the change in average payment days in Group A and Group B is the diff estimate of the average effect of the regulation. Rigorous evaluation is useful to find out if regulation works. The diff provides a powerful method to do so, and therefore helps to improve the design of future policies. For more information, visit the JRC website on macroeconomic evaluation.
All right, so this graph has summarized what different diff does. Right, so here is the control group, and here is the treatment group. Right, in the pre-intervention period, nothing happened. They have a difference, and that I think about it as a first difference. The assumption is that these two groups are similar in the sense that yes, they have a difference, but they follow a similar trend. Okay, and so if there's no difference, this is where the treatment group would be. Right, so same trend, right, after the intervention. But since the treatment group, not the control group, got the intervention, now this is where the treatment group is. And subtract by the counterfactual, which is give us from this first difference, we got this causal impact of the policy intervention or other kind of intervention or treatment. And so that's the idea of diff and diff, right? Using a treatment control group and this idea that they have parallel trend. And so in practice, one might want to cover careful in terms of, okay, do they really have parallel trend? How if we have more period before this intervention and so get some more idea. Okay, so that's different diff in terms of getting causal impacts for using observational data. For a lot of these issue where we cannot directly interpret correlation between two variables to be a causal one, it could be due to many reasons, and this is what we usually call the endogeneity issue. One reason is that there might be omitted variable. Okay, so what is that? So suppose we want to know the causal relationship between X and Y, and so the direction, there's an arrow there, right? So and so we know to what extent X the change in X caused the change in Y or something kind of like, let's think about X as some sort of interventions. The problem is if we just look at the correlations, again, if we go back to our example of education and schooling, there might be some omitted variable, right? So maybe to some extent, education make people more skillful, more human capital, more knowledgeable, and that increase earning. But maybe those people who got more educations, they might be more persistent, they work harder, and so on. And so even if they don't go to uni or they don't got a lot of years of schooling, they would have high income to begin with, or higher income to begin with. So maybe the gap between people who have more schooling and people who have less schooling, in part is because this kind of omitted variable. We don't observe how hard people work. We don't observe how creative they are, how persistent they are, and so that or they're intelligent and so on. And now we have these things, omitted variable. And so we don't know whether one more year of schooling increase people's earning by 12% or 10% or 8%. We want to know the causal impact. If that kind of person, a same group of people got one more year of schooling, how many, what percentage of earning on average they would got? So that's causal impact. And one way to deal with it was, well, and this is some people early on tried to do. In some country, initially people think, okay, in this omitted variable, maybe intelligence is a big factor. Usually don't observe that, but in some country, okay, some people, they apply to the R-force in US and some other country, and as a requirement, they need to do an IQ test. And so in that subsample, they can control IQ, well, whatever it was, in terms of affecting their earning. And then they sort of, okay, it turned out that they control for it, and the correlation is still really strong. And so, so maybe you sort of, in a way, this is the idea of conditional unconfoundedness. So basically, you say, okay, U is small enough once we put in a lot of data there. So you control for it in a way. But the thing is, well, people still, well, yeah, maybe IQ, you can control for it and still don't see the coefficient change a lot, but maybe there are other things. Maybe you can't measure how persistent, how hardworking people are. So the potential drawback is that while you might still have a lot of this confounding variable that you haven't captured yet. So one way to cover deal with it is to what we call using an instrumental variable, IV. The idea is that if you have some sort of variable, that only affect X, the variable that you really want to get its causal impact, but not anything else. And you know, IV itself is uncorrelated with other unobservable, and its impact on Y is only through X. Okay, so go back to our previous example. Let's X is year of schooling, Y is earning. U is maybe intelligent, persistent, and so on. Okay, if we can do experiment, we randomize people's year of schooling X, and that's it. But we can't. So can we think of some instrumental variable that affect people's year of schooling, but not earning directly, right? So for example, in some places, some charity organization, some university, we say, okay, we're going to give out scholarship, but we have this fixed number of scholarship. So for all those who are eligible, we can't give it to all. So for those who are eligible, we just whoever won the lottery, I call it. So in those cases, you can, if people got data and say, okay, whether people got scholarship or not, it probably affect people's decision to got year schooling if financial constraint is a factor, or maybe sometimes which school they go to. And that, because it's through a lottery, is covered, well, it's random. And therefore, it's uncorrelated with this unobservable. It's not going to affect people's earning because the lottery itself is not going to affect people's earning, except through affecting people's decision to take enroll in a university or not. Okay, and that changed years of schooling and so on. So in that case, the instrument variable is going to be helpful for us to get the relationship from year of schooling and earning. It doesn't have to be earning. There's other benefits of education as well. And the vast literature in that study is just putting down, okay, the causal relationship between a year of schooling and earning, it varies from country to country, but tend to be quite large, and on the magnitude to 8 to 15%. And that's instrument variable. Here's another example where people use this innovative idea. Again, it comes from Joshua English, many years before he got the Nobel Prize, and Bill Evans. So people who study labor market, they interested in labor supply, how people decide how many hours, whether or not they work in the labor markets. And one thing that we know, or so the hypothesis may sort of affect people's labor supply, particular women, because historically the labor force participation of women has been lower than men. So they want to know, okay, whether children and their parents have a causal the number of children, whether they have a causal impact on parents' labor supply. The problem though is endogeneity, right? There's a lot of factors affecting people's decision to have children and affecting people's decision to have to work or not. Okay, child care, whether family have other incomes, all kind of reasons. So a correlation, it does not mean causality, and maybe or maybe sometimes the labor, the job is so demanding and they can't have children and so on. Right? So they think really hard and come up with a really innovative instrumental variable. And that is the gender composition of first two children. Okay, so this is done in the context US. We know that the gender of children is going to be random. Right? The biological science tells us that. And in US, not everyone, but in the sample there, there's a kind of a preference, a small preference for parents to have a mixed gender of the children. So to cover triage, so not all parents, but a large enough share of parents would say, okay, we have one boy and we have one girl. Here the order doesn't matter that much. And they say, okay, that's it, no more child. We got one boy and one girl. For some parents, they have the first two children, they're both boys. Okay, and so they might, okay, it would be nice if we have a daughter. And so, okay, perhaps have one more child. And similarly, if the first two children are both girls, they might say, well, maybe try one more and see whether we got a boy. Right? So we know the gender of children is going to be random. And so the gender compositions of the first children is going to be random, whether they have the same genders or not. Same gender or not. And so that kind of randomness, that kind of experiment done by the nature, induce whether like a subset of parents, whether they have 2 children or 3. And that's precisely using that instrument variable, which is for those who have 2 or more children, for those parents with 2 or more children, whether the genders of the first 2 children are the same or not. Okay, and using that kind of randomness, okay, they got exogenous variations in number of children, 2 or 3, and figure out, okay, indeed, the number of children impact people's labor supply decision, to what extent they work full-time, part-time, what kind of job they take, and so on. And so in this case, yeah, so they sort of use observational data, how many children and the general composition people have, using natural experiment and tease out causal relationship. Okay. So that's IV methods. And that's all I have on econometrics. I've got some practical advice on doing research and about species. So if you you can read a lot later on. I think we've run out of time. Yeah. Should I just stop here and answer questions, or quickly go through a few slides?
Do you guys have a question for action? Anyone online?